All right, this lesson is on triangle congruence proven by the side-side-side postulate or the side-angle-side postulate. Then we also have the angle-side-angle postulate and the angle-angle-side theorem. So we're going to quickly go review some things that we need to use the side-side-side and side-angle-side postulates. So start out, we got to remember included angle and included side. Included angle is an angle between two segments, and included side is the side between two angles. So starting off at the diagram at the right, the included angle between segment AB and segment CA is of course angle A. The included side between angle A and angle C is side segment AC. So we quickly can see that there's a little bit of a pattern here. So the included angle between BC and CA is going to be angle C. It's the point they share in common. And the included side between angle B and angle C is a segment that contains those 2 points as endpoints, segment BC. The included angle between segment BC and segment AB is of course angle B, and the included side between angle B and angle A is segment AB. Vocabulary word for today is postulate. It's a statement that is accepted as true without being proven true. It's those things in geometry that we just accept as given facts. So we're going to underline the correct words to complete the sentence. You can use properties, postulates, and previous proven theorems as reasons in a proof. Remember that statements go on the left, reasons go on the right, and the reasons are the logic or the arguments we're making to prove the statements that we make. So what is a postulate? It is a statement accepted as true without being proven true. So our first postulate in this section is postulate 4-1, the side-side-side postulate. If the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. So looking at the figure at the right, segment AB is congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF. So I can say that triangle ABC is congruent to triangle DEF. So how can we use the side-side-side postulate in a proof? So here we have a given statement. BC is congruent to BF. segment CD is congruent to segment FD. And we want to prove that triangle BCD is congruent to triangle BFD. Since we have two pairs of sides that are congruent, what else do we need to prove the triangle is congruent by side, side, side? Okay, so it's obvious that we need a third pair of congruent sides. But the triangles share a side, segment BD, and so it's obvious we can use the reflexive property to do this proof. So we're given that segment BC is congruent to segment BF, and segment CD is congruent to segment FD. Both of those are given. So we can say that segment BD is congruent to segment BD itself by the reflexive property of congruence. And since we now have three sides congruent, we can say that triangle BCD is congruent to triangle BFD by the side-side-side postulate. Another postulate we're going to learn about this section is postulate 4-2, the side-angle-side postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So we're going to use the figures below to complete each statement. Triangle DEF is congruent to triangle TRS by the side-angle-side postulate. And triangle ABC is congruent to triangle FED by the side-side-side postulate. So let's use the SAS postulate to look at a problem. So what other information do you need to prove that triangle LEB is congruent to triangle BNL by SAS? We're given the angle L is congruent to angle B. So circle the angles that are marked congruent in the diagram. So that would be ELB and NBL. All right, so we want to circle the sides that form the angles that are marked congruent in the diagrams. So to form BL angle BELB, we have BL and LE, and I didn't do these in order. BN and LB form angle NBL, and then BL and LE form angle LELB. So complete each congruent statement. Segment LB is congruent to segment LB by reflexive property, and angle BLE is congruent to angle LBN. All right, and that's given. So underline the correct words to complete each sentence. Proving triangle LEB is congruent to BNL by SAS requires 2 pairs of congruent sides and 1 pair of congruent angles. The diagram shows congruency of 1 pair of congruent sides and 1 pair of congruent angles. So to prove the triangle is congruent by SAS, we still need 1 pair of congruent sides and 0 pairs of congruent angles. So to prove the triangle is congruent, we need to prove that segment NB is congruent to segment EL. All right, so that's all we're not going to actually do the proof. That's just what we need to prove in order to solve this problem. Let's go on to the next problem, problem 3, identifying congruent triangles. Would you use SSS or SAS to prove the triangles below congruent? So look at the triangles. Please pay attention to where the congruent marks are on the angles. Okay, so we're going to use SSS if we have 3 pairs of sides congruent, and we're going to use SAS if we have two sides congruent and their included angle. So first off, we're going to write true or false for 19 through 21. The diagram shows congruence of 3 sides. That is a true statement. In the triangle on the left, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. That is a true statement. In the triangle on the right, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. That is false. The included angle of the object on the right is actually where there are 1 marks and 2 marks. So we can't use SAS. So we're going to use SSS because the included angles are not between the congruent sides. So when you come in this on Monday, you'll have some worksheets and proofs to do using the SSS postulate and the SAS postulate, as well as what we're getting ready to go over. So let's do our lesson check, make sure we understand what we're doing here. Your friend thinks that the triangles below are congruent by SAS. Is your friend correct? So are 2 pairs of corresponding sides congruent? Yes. Is there a pair of congruent angles? Yes. Are the congruent angles the included angles between the corresponding congruent sides? The answer is no. So are the triangles congruent by SAS? They cannot be proven congruent by SAS because congruent angles are not included angles. Perhaps there's another way we can prove them, but we'll have to wait a little bit to see that. So let's continue on to triangle congruence by ASA, which is angle side angle, and AAS, which is angle angle side. Cross out the figures that are not triangles. Quick review, shouldn't take long. That one's not a triangle. That's not a triangle. That's not a triangle. A triangle is a polygon with 3 sides, and a triangle with a right angle is called a right triangle. All right, vocabulary word is corresponding. Corresponding means similar in position, purpose, or form. So when we look at congruent triangles, we're looking at corresponding sides and corresponding angles. So we're going to look at the drawing at the right, and we're going to match column A to column B. Segment BC has 3 lines, so it goes with segment YZ. Angle A is between the 1 dash and 2 dashes, so it goes with angle X. Segment AB has 1 line, so it goes with segment XY. And angle C is between 2 and 3 dashes, so it goes with angle Z. And I did that out of order. And segment AC goes with segment XZ, and angle B goes with angle Y. All right, so let's go on to our lesson. Postulate 4.3 is the angle side angle postulate. If 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the 2 triangles are congruent. So in our drawing, angle A is congruent to angle D, segment AC is congruent to segment DF, and angle C is congruent to angle F. So we have an angle, a side, and an angle. So triangle ABC is congruent to triangle DEF. So how is the ASA postulate different than the SAS postulate? The ASA postulate uses 2 angles and an included side, while the SAS postulate uses 2 sides and an included angle. Really is that simple. So let's use the ASA postulate. Which 2 triangles are congruent by ASA? So we're going to name the triangles and list the vertices in corresponding order. List the vertex with the 1 arc first, and the vertex with the 2 arcs second, and the 3rd vertex last. So the first triangle is triangle GHO. The second triangle is triangle INF. And the last triangle is triangle CAT. So angle G is congruent to angle I, which is congruent to angle C. Angle H is congruent to angle N, which is congruent to angle A. Segment HG is congruent to segment NI, and segment HG and NI are congruent to segment AC. Just check and see if you're paying attention there. The congruent sides that are included between congruent angles are HG and AC. So we can write a congruent statement for triangle GHO and triangle CAT. And our logic would be something like this, our reasoning. Triangle GHO and triangle CAT have 2 pairs of congruent angles and a pair of included congruent sides. So how would we write a proof using ASA, which is the most important thing? Here we have a flow proof. Given that angle CAB is congruent to angle DAE, segment BA is congruent to segment EA, and angle B and E are right angles, prove that triangle ABC and triangle AED are congruent. Given that angle B and angle E are right angles, all right angles are congruent, so we can say that angle B is congruent to angle E. I did that in the wrong way. Bad flow. Okay, so that's going to be angle E. Given that BA is congruent to EA, that's given, and we're also given that angle CAB is congruent to angle DAE. So all right angles are congruent. That tells me that angle B is congruent to angle E. So by the ASA postulate, I can say that triangle ABC is congruent to triangle AED. Now the last thing we're going to look at is not a postulate but a theorem. It's the angle side theorem. So that means we have to prove this, but once we prove it, we can use it for the rest of the class. If 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of another triangle, then the 2 triangles are congruent. So the non-included congruent sides of triangle ABC and triangle DEF are segment AC and segment DF. So let's write a proof using AAS. Given that angle S and angle Q are congruent and RP bisects SRQ, prove that triangle SRP is congruent to triangle QRP. How do we know which angles in the diagram are corresponding angles? It is the angles that have the same number of arcs. So S corresponds to Q, and then we can figure out the rest correspondingly. Yeah. So here we go. Angle S is congruent to angle Q, that's given to us. RP bisects angle SRQ, that's given to us. So we know that SRP is congruent to angle QRP. That's the definition of an angle bisector. We also know that segment RP is congruent to itself by the reflexive property of congruence. So now we have two angles and a non-included side that corresponds because it is the same segment. So angle SRP is congruent to a triangle QRP. So we can use the same logic to determine whether triangles are congruent. Are triangles PAR and triangle SIR congruent? The congruence marks show that angle A is congruent to angle I. See, this is why videos go on longer if we get the letters right in the first place. Angle I and segment PR is congruent to segment RS or SR. So what other corresponding parts exist? Do we know of any? We know that angle PRA is congruent to angle SRI because those are vertical angles. In addition, so now we have two angles and a non-included side which are corresponding. So by AAS, the two triangles are congruent. All right, let's finish up with our lesson check. Suppose that angle E is congruent to angle I and segment FE is congruent to GI. What else must you know in order to prove that FDE and triangle GHI are congruent by ASA or by AAS? So let's label the diagram it right. We have triangle D, FDE, and triangle GHI. All right, so to prove the triangle is congruent by ASA, what else do we need? We need two pairs of congruent angles and a pair of included congruent sides. And to prove the triangle is congruent by AAS, we need two pairs of congruent angles and a pair of non-included congruent sides. So if you want to use ASA, we have to say that angle F and angle G must also be congruent. And if we want to use AAS, we have to say that angle D and angle H must also be congruent. So I know this is a long video and it went a long time, but it's over the weekend and just take time to digest everything. On Monday when you come into class, you'll have two worksheets to complete. Two worksheets to complete. They'll have a lot of proofs on them. So take your time, go through the theorems and postulates. Don't forget about things like the reflexive property, vertical angles are congruent, all these different things that we can use to work on the proofs and try to solve the proofs that you're given on Monday. I'll be back on Tuesday, and you may or may not have notes on 4-4 to go over for Monday night. Hope you have a good weekend. I will see you on Tuesday.